First problem, zigzag grid traversal with skip. We're given a grid m cross n and it's of positive integers. We are told that we need to move in zigzag pattern, which is basically defined here. Starting at 0, 0, move right within a row until the row end is reached. Drop down to the next row and then go in the backward direction. So basically start from here. If this is 0, 0, suppose this is, you go here, 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 like this until all the rows are exhausted. The answers are uh, pushed inside a vector. And the last thing is we need to alternate. So we need to skip few. The first element will pick, the next will skip, pick, skip, and this will go on. This can be skipped or picked based on whatever we have, have the state of skipping the element. If the last element was not skipped, then this will be skipped, otherwise vice versa. And that's it. The constraints are small enough, so we can brute force this. I don't think there exists any other way either. So let's have an answer declared here, vector of answer. Here we will have a boolean variable called skip. Initially it will be false. Another boolean to tell which way to move, either forward or backward, right? So if move forward, initially it will be true, and let's traverse the entire array row wise. So this is for every row. Do this thing, traverse row. So I'll pass the grid row value. This is the row we need to traverse. Move forward variable and skip variable. So I'll pass this by reference so that it changes inside this function, right? And move forward will also change here for every row. We can return answer here. I'm not passing the answer in that function, so let's declare it outside. So this is not going to return anything. Let's have the first argument as grid. Actually, since this is the only this is just row, so vector of int move forward skip. This is passed by reference. Let's get the grid size inside variable n. Let's start from 0 if move forward is true. So if move forward is true, then start from 0, otherwise start from n minus 1. Also, let's have an increment variable so that I can increment or decrement I based on move forward. A plus 1 or minus 1. So I is already declared outside. I should be less than n and I should be greater than equal to 0, and I should increment this much. If skip is true, then we'll skip. Otherwise, if it's not true, then I will add that to my answer. Let's call this row instead of grid. and let's skip alternate the skip variable and just return. That's it. I'm sorry. So this is linear time complexity O of m cross n, and space complexity is O of 1. Let's submit it. Actually O of n, because we have answer variable. Alright, second question. Maximum amount of money robot can earn. We are a robot. We have a grid m cross n. We are starting from 0, 0. Need to reach the bottom right corner. Every cell has a coin ij. If coins ij is greater than equal to 0, those coins will go to the robot. If it's less than 0, which means the robot is going to lose, basically a robber is going to steal this amount of value, coins of ij, absolute value of coins of ij, because it's less than 0. Just the sign just signifies that it's going to be robbed by a robber, this many coins, right? The robot has special ability to neutralize robbers at most 2 cells. So the robot's value, total coin, by the end can also be negative in certain cases, and we need to find the maximum profit of robot. So just straightforward, we will brute force it and then memoize it. It's a DP question. So I'm going to do it top down, but this can be done bottom up as well. So let's do this. Initially, I'll declare the cache later. Let's have a solve function. I'll pass coins starting at 0, 0. The third state will be the neutralize, right? The neutralizability. Initially, it will be 2, and then I will reduce it as I use it. So this is the solve function. The first argument is coins. Row, column, neutralize. If row is less than 0 and row is greater than equal to coins dot size, so if it's within range, valid range, or actually out of valid range, and similarly for column, sorry, coins 0 dot size. If this is the case, then return what? We need to maximize the profit. So we'll return something that's not going to affect the answer. It can be the most minimum answer that is possible, and that can be a scenario where we have a grid of 500 cross 500 and all of them has a negative 1000. So it's going to be 500 500 cross 500 will be 25 into 10 to the power 4, so 2.5 into 10 to the power 5, something around that. So we can have something of the magnitude 1e6, or probably yeah, 1e6 will work. Let's have that. The next thing is, if I am at the destination and column is equal to coins 0 dot size minus 1. If I'm at the destination, then I'm going to check if there is a neutralize ability that I have right now. If it's greater than 0, then I'm going to return uh, 0. If it's negative, if it's positive, then I'm going to return that, right? So I can return max of 0 or coins of row column, right? If that is not possible, neutralize is 0, then return whatever I have here. I need to use it. I have to use it. Alright, let's have an answer variable. This can be also, something most minimum, so it can be minus 1e6 as well. If the neutralize ability is greater than 0 right here, and the coins value and column value is also less than 0, then I should use it. I can use it either to go right or down. The robot mind this, that robot can move only towards right or down. I forgot to mention that. So I need to maximize answer. Since I'm neutralizing, I'm not going to add anything to the contribution. I'm just going to call this function for either row plus 1 and reduce the neutralizability by 1, and the other choice is go down, so column plus 1. I can do that, or I can always use that even if it's negative or so, right? So I can still choose to not use the neutralize ability even if it's greater than 0, so that I end up using it later on, right, in future when I get a really negative value, right? So here I am going to get some contribution, and that is coins of row column. All right, and that's it. Let's return the answer here. Let's see if this much works. Then we'll memoize it. We have 3 states: row, column, neutralize. So let's declare a cache outside so that I don't need to pass it. It will be a 3D vector. Size will be coins dot size plus 1. Coins of 0 dot size plus 1, and finally 3, not 2 but 3, or let me write it like 2 plus 1. Initially it will be, let's have int minimum, right? I didn't choose -1 because it can affect the answer. So right here, if cache of row, column and neutralize, if it's not equal to int minimum, return this value. And update the cache here if it's not in the cache. Let's see if this works out. Time complexity will be O of m cross n, because row column neutralize just 2. Alright, this works. Let's move to the next question. Minimize the maximum edge weight of the graph. So we are given a graph, not a tree. We have 0 node till n-1 nodes. Every node has some outgoing incoming edge. All of the parallel edges that we have, suppose like 2 has a edge going from itself to two other nodes, right? Here this will be 1 and 2, right? So we are always going to have unique edges if they are parallel. It's never going to be 1 and 1, doesn't make yeah, it doesn't make sense. I mean, it makes sense, but in the constraints is given probably that it's never going to be. There may be multiple edges between a pair of nodes, but they must have unique weights. All right, so my bad. So between a pair of nodes, there can be multiple edges, but they are unique. They have to be. All right, so the constraints are high enough, and we are told that we have to satisfy these three conditions. What we can do is we can remove some edges from the graph, possibly none, such that node 0 must be reachable from all other nodes and the maximum edge weight in the resulting graph is minimized. So the maximum edge weight in the resulting graph, suppose this is the graph, and suppose I have, removed all the edges, all the required edges that needs to be removed. In that case, it'll be 2 because 2 is the maximum edge possible here. But after removing few edges, we have certain scenarios, right? Among those scenarios, I want the maximum or the minimum maximum edge. This is confusing, but for every scenario, I'm calculating the maximum edge, and out of the all the scenarios, I am taking the minimum of them. So it's the minimum of the maximum edges. So these kind of questions where we have to find minimum of the maximum things or maximum of the minimum things, this always points towards binary search. That's the first thing. The next thing is we are given that each node at most should have threshold outgoing edges, so it should not have more than threshold outgoing edges. Here uh, we have a threshold of 2 and there is no edge which is having a threshold of more than 2, so we don't have to worry about, we can't introduce a edge, we can always remove it. So that's there. Here let's see, threshold is 1 and we have a edge or node 1 which has 3 outgoing edges, so we need to remove uh, few of them, so that I end up having we need to remove 2 of them and we end up removing 3 and 5 because from one I mean the edge with one weight can also be used to reach 0th node, so we are able to reach 0th node. So the tricky part here is we need to reach 0th node, right? Let's forget about the threshold. Let's see, if I want to reach 0th node from every other edge, that is equivalent of saying that from 0th node I want to reach every other node, right? So what we can do is, instead of, we obviously have to create a adjacency list. So what we can do is we can create the adjacency list with inverted edges, right? In that case, I will have something like this. Here, this will be somewhat like this, like this, like this, like this, like this, and finally like this. All right. So from 0, if I want to reach all the other nodes, I can do a DFS, and for every path from 0, I can use that to see how many nodes I'm able to reach. If I'm able to reach n nodes, then that path is valid, at least for now, right? If I have other paths as well, but I can't reach all the nodes from these paths, but I can reach all the nodes from this path, right? In that case, this path is valid, And since I'm doing a DFS, I can always keep track of what's the maximum edge that I've found. So by the end of a DFS, I will have a valid path, and in those valid path, in that valid path, I will have the maximum edge that I encounter. So here I can use that maximum edge that I encounter on the binary search. Right? Anyways, we need to do a binary search because we have that kind of nature of the problem. So we have a range of what edges can it be. It can be from 1 to 10 power 6 because this is the weight in the constraint. I will try to find a middle value in this range, use that middle value as the maximum weight, and try to do a DFS from the adjacency on the adjacency list with inverted edges starting from 0, and that will give me either, you know uh, so basically that will give me if that DFS is valid or not based on the maximum edge that I've passed. If it is valid, then I try to find a lower value because I need to minimize the answer. Otherwise, we find a larger value. So this can be confusing in words, but let's code it so that it's more clear. First, we need to create a adjacency list. That's the first thing. Since the adjacency list is going to have a weight as well, so instead of a pair, let me take vector, and this will be of size n because we have n nodes. We will traverse the edges vector. All right, and since this is reverse inverted edges, right? So I'll take the destination edge as the source and push back the source node along with the weight. So this will be edges of I0 and edges of I2. So I have the uh, adjacency list done. I need to do a DFS, but for that I need a binary search. In that binary search, I'm going to do a DFS for every middle value that I fix. So the last value can be 1e6. Let's have a one greater value, or probably 1e6 is fine. Let's have answer as one greater value, 1e6 plus 1, so that because there is possibility that it's impossible to satisfy all the conditions. In that case, I will end up never having a valid DFS and always having answer fixed as this. So by the end of the binary search, I will have this. So I can check against this. If it's still this value, then I'm going to return -1. Right. So while start is less than equal to end, I'll get the middle value plus end. Since I'm going to do a DFS, right, I need a visited vector. So for every DFS, I'll need that. So let's declare it inside the binary search function. And if since the DFS also needs to satisfy this part, right? This part of reaching all the other nodes. So I can just use the DFS to get me from 0 the the number of nodes that I'm able to visit. So DFS using on the adjacency list starting from the 0th node with this as the visited vector and this as the weight, mid as the weight. So if it's equal to n, that means I was able to visit all the other nodes, right? That means I was able to visit all the other nodes. I can try. I can take this as an answer, but also try for the further lower value. Otherwise, just go right. Let's return answer, but let's not just return answer. Check if it's still 1e6 plus 1. If that is the case, then return -1, otherwise return answer. Let's have a DFS function returning an integer value. First argument as adjacency list. I'm sorry. Second argument visited vector. Third argument is the node. Last argument is the weight, or let me call this max weight. Here, initially, the 0th node itself is going to have one node as a count, right? So let's have a total nodes count starting from 1, because the 0th node is also a node, because I'm checking against n, so I need to include 0 as a node as well. And I equal to 0. I will traverse the adjacency list through all the neighbors from node. The next node, let me take that inside a variable next node. This is a vector, so I need the first element and the next node. All right. If the max weight is greater than equal to adjacency list, I mean not the adjacency list, the weight of this node to next node edge, that is the first element, and it's not visited. All right, this next node is not visited. That means if this is 0, this will be true, and it's valid if it's smaller than the max weight that I have fixed. In that case, I will count this and also visit it. Total nodes will be counted. So for that, I will call the next function. ADJ visited next node and max weight. Sorry, this will be next total nodes, and that's it. I am good to return the total number of nodes. Alright, so let's see if this works. It does. Let's submit it. Okay. Let's include this value as well. Let's see if this works. Okay, there is some mistake. Let's see what it is. Starting from 1 and checking here if the answer is still this value. If it is, then return -1, otherwise answer. I'm checking here if the max weight is greater than equal to the weight, and this is still 0. marking it. Okay, I think I should visit the 0th node as well. Right, since I'm always marking the next node, the first node needs to be marked here itself. We can have different kinds of implementation otherwise. So let's remove that. Yeah, let's submit now. Time complexity time complexity will be O of n log n. Since we are doing a DFS inside every binary search, so in worst case will be O of n log n.